The next topic for our discussion is speed of sound in different medium. So firstly, if I want you all people that please, have you ever noticed that when you are moving from one medium to another, that is firstly you are moving in air. When you are moving in air, after that when you are set into the pool, water pool, you are told to move with the same speed as you was moving in air. Are you able to move in the same speed in both the mediums? No. So it means if person is unable to move with the same speed, light is unable to move in the same speed, hence our sound is also unable to move with the same speed. So if firstly we will compare the speed of light and speed of sound, so sometimes they have given you the example of blacksmith, but instead of that I will compare the example which you are aware. Normally when you see the cricket match on a TV screens, what you notice that when you are able to see that person or the cricketer or the batsman is going to hit the ball, you see that striking of the ball with the bat is first, but the sound tuck comes later on. So it indicates that sound is having less speed as comparative to light. So if we find its value, so according to value, speed of sound in different medium, if we compare speed of light and speed of sound, speed of light in a medium or in air is 3 into 10 raised per 8 meter per second. But speed of sound in air is 330 meter per second. So if we put zeros, so 8 zeros are behind the 3. So it means it's very much greater value rather than 330. So speed of light is very much greater than that of speed of sound. That is the reason you see that batsman striking first and you hear the tuck sound later on. So if we compare the speed of sound with mediums, different mediums, so based upon the mediums we should know the two factors on which the medium's speed depends. First is elasticity, second is density. Elasticity, we have told that the particles of the medium must have the tendency to vibrate. Second, the density, number of the particles which are going to vibrate. So if more particles are there, more density is there, more speed is there. Means more closely, this particle is very much close to another. So if it vibrates little also, then it is able to transfer the energy from one particle to another. Hence it is able to transfer the energy to another next one, to next one. But if the particles are close, instead of closely they are touching each other, it indicates they are very easily transferring the energy from one particle to another. So speed of light in more densities, speed of sound in more density is more, and speed of sound is less with the density less. So it means elasticity is more, sound ki speed is more, density is more, speed of sound is more. But here it is inversely relation. They have shown that if we are drawing the relation, it is under root E by rho. E is elasticity, modulus of elasticity, rho is density of the medium. So if we consider solid materials, this modulus is E is modulus of elasticity. I have told this modulus is Young's modulus of elasticity. If we are talking about fluids or liquids, it is Bulk's modulus. So now Newton has considered to find the speed of sound or the factors it want to find. So he has considered the experiment and he noticed that when sound is going to pass through a medium, no temperature changes. Temperature is not going to change. If temperature is not going to change, we say such type of change is known as isothermal, in which the temperature remains constant. Under such condition, the elasticity changes to pressure. The elasticity changes to pressure. So if E is equals to pressure, our formula of speed of sound E by rho is changes to P by rho, under root P by rho. When he calculated the values by putting the value of different things P and rho and V, he is able to calculate the value 279.5 meter. But actual value of speed we have noticed over here, that is 330 meter. So 330 and 279.5 is much less. So these two are not comparable. They are two different values. Hence this value was not considered. But later on another scientist which is known as Laplace, he has done another experiment and he noticed that temperature is not changed due to no exchange of heat. If exchange is not there, exchange of heat is not there, we call such type of change as adiabatic change, and hence in such type of changes elasticity is gamma p. What is elasticity? Gamma p. What is gamma over here? It is a ratio. What is its ratio? Specific heat of constant pressure and specific heat at constant value. Medium की specific heat when the pressure is constant, and medium की specific heat when the volume is constant. So it means our elasticity of modulus is gamma p, and hence he filled the value in the given formula, then V is equals to gamma p by rho. When he substitute all the values over here, he found the resulting value of speed of sound is 330.7 meter per second. So which is very near to it. Hence the Laplace consideration was there that speed of sound depends upon the adiabatic change. Then speed of sound in different medium, if we are talking about, it is more than, according to this formula, it is more in solids, less in liquids, very much lesser in gaseous state. So if they have taken the examples also, steel, solid they have taken steel, its value is 5100 meter per second. If they have taken in liquid water, the speed of sound is 1450 meter per second. If they have taken gas, air, then the speed of sound is 330 meter per second. So these are the speeds in different medium. So they have given you the chart or the box in which they have mentioned the speed of sound in meter per second of the different things, gases, liquids and solids. So hence you can calculate from here. So now they have shown you example of sound in steel also. That also you can read by your own and you are able to understand. Now next come, that is factors affecting the speed of sound in a gas. Now we have done the factors on which it depends, but these are the factors which are affecting the dependence. If we are talking about the gaseous state or the gaseous medium in which the sound is traveling, we will talk about few of the factors which are affecting. Number one is density. As we have done from the formula V is equals to rho p by gamma p by rho, it is very clear that velocity is inversely proportional to square of the density, square root of the density. So if we want to calculate, this square is going to move in this side, so 4 times. If oxygen we are talking about, तो oxygen का जो है relation, that is 16 times the density of the hydrogen. Hydrogen is one molecule, 16 molecule of oxygen are there. So therefore the speed of sound in hydrogen is 4 times the speed of sound in oxygen. Density कम है तो वहाँ पे factor जो है वो effect करेगा. Then comes effect of temperature. We know that whenever the body is going to heat it up, its density decreases. उसकी density decrease होती है. क्यों? क्योंकि उसकी volume expand करती है. Volume expand करेगी, it means the density decreases. Density decreases, speed increases. So the speed of sound in given gas increases with increase in temperature. Temperature increases, density decreases, speed increases. So it is going to be calculated with the formula Vt is equals to V0 plus 0.61 T. So they have given you this. It means they have calculated with the example कि firstly initial temperature was 0, then temperature was 25 degrees Celsius. Speed of sound we know that is 330 meter. So at V25 we want to calculate it, and V0 is 330 meter plus 0.6 into the T. T means temperature, and the temperature speed comes out to be 345.25 meter per second. So this will be the speed when the temperature rises from 0 to 25 degrees Celsius. Then factor is humidity. What is its effect? If humidity increases, the air particles containing dust particles, that dust particle are going to be settled down. If the dust particle are going to be settled down, the vapor density is 5 by 8 times the density of the dry air. Density of the vapor, water vapors are 5 by 8 times the dry air. It means density of dry air is more. So moisture increases, density decreases. If density decreases, we again know the speed increases. So in humid air, if the atmosphere is clear, automatically the sound reaches very fast. Then effect of direction of wind. If I am moving in forward direction, and the sound is air is also, or the wind is also moving in the same direction, my sound reaches fast. But if I am talking about that speed is moving in this, sound is moving in this direction, but air is moving in this direction, in this case sounds reaches to the destination is less. So speed of the sound is less. So it depends upon the direction of the speed also.